Hi there, I thought I'd give you a video response to this. Essentially, I've got a sort of solution, which I don't know if this is entirely what you're looking for, but I'll walk through this anyway. It's a little bit involved in terms of how it's all put together, but hopefully it's understandable. So what I've got here is I'm basically creating a line, and I'm just setting up some basic parameters here, which is going to define sort of the height of the wall and its outer perimeter. So the origin I've gone off at 10 and length of 5 should be fine. We're then resampling the line, and we want to get a curve U out of this thing. So we're going to come in here, I'll set this to 100, oh, maybe not 1000, 100 will do. Go and turn on curve U here. And then I'm going to create an attribute wrangle. And what I basically want to do with this is I want to use this to define the profile, which is the sort of the brick you were looking for. So I'm going to start by saying we want to say at p plus equals our normal. Should probably give it some actually. So let's just say at n equals set 100. Yeah, that should be good. So I'll say at p plus equals our normal direction. So by default, this is just going to displace it along the normal. You can see there. So I want that as my direction. I'm going to say I want to do that based on that times curve U. So I'll do that, and you can see, okay, I've got an angle. So what we're going to do is we're going to say create a ramp. We're going to call this profile, and plug in our curve U into that. So now if I create this, I can go ahead and define how much this thing displaces based on this. So you can see as I move this around, I'm getting a different profile. But obviously you just wanted that top brick. So if I wanted to come in here and define that on the top of a wall, I can come in here and I can go, okay, give me, we're going to fit the curve U between some, let's call this min start, I guess. This will be where our curve starts affecting the line. Then 1, because the max value out of curve U is 1, and we'll fit that to between 0 and 1. As I hit create here, we've got our profile, but if I start moving this up, you can see it starts to only really affect it at a certain point. So I'm going to say, let's use maybe 0.8 as that effector. That's pretty good. And the last thing I'm going to put on here is a multiplier. So I'll say CHF and global mult, something like that. And so this will, need that for now. This will be the amount of displacement we want. So I'm going to, I might set this to a B-spline, I'll move it over here, and I'll just kind of create something similar to what I saw you were making here. That should do for now. Cool. So now I'm going to put down a facet, and the reason for this is if we look at the number of points we have on this line, I can go even higher with this value. We want loads of resolution to define our curve, but once it actually comes to something that's dead straight like this, we don't need that much resolution. So I'm gonna, on the facet, I'm just gonna go remove inline points, and it's gonna compute this. By lowering this value, we can get more back. So if I go, sorry, that wasn't lowering. Let's go add another 0. You can see I get more points back here. Take the 0 off back to default, and we get this. This is pretty good for now, so I'm gonna leave that. Then I'm gonna do a revolve, and this is going to basically create the outline of our wall. I'll give this some more divisions, maybe 100 would do for this. And that's cool. That gives us the outline of our wall. So now I want to create some normals. So if we have a look, what was I doing here? I think we need even higher res. Want to go 1000? Okay, screw it. Let's go 1000. What I'm doing here is basically creating normals that are going to define where our extrusion goes. So what our poly extrude node does by default is it's going to, as I do this extrusion, it's kind of doing what I want, but it's attempting to compute the normals itself. So we're going to tell it to use the point normals, but instead of pre-computing them, we want to use an existing attribute. So let's go ahead and create that. I'm going to say attribute wrangle here, and I'm basically going to say our normals equals, what do we want? Normalize. So we're going to get the bbox center of ourselves, so that's input 0, and we're going to subtract p from that, and that should, when I look at this, should give us some normals that are facing inwards, which it looks like they are. Obviously they're all pointing towards the center, so we don't want that in y. We're just going to say n dot y equals 0, and that'll give us some pretty good normals. So now when we do our poly extrude along the existing attribute, I'll just turn on output back here, you can see we've got something that isn't causing overlapping polygons and all that annoying stuff. So that's the basis of our wall. So to get the bricks, I'm just going to give some better normals here. So to get the bricks, what I was doing was basically, I'm taking a tube and connecting it here. And as you can see, if I reference this on and turn this on, this is basically referencing our, using this as sort of like a bounding object. So what I'm doing here is basically setting up how I want these bricks to look. So if I come in here and go put my original values in, 11 and 50, you can see here, this is kind of how the brickwork's going to end up looking, and we're going to cut these shapes out of our wall. So I'm going to say blast, we just want to blast away the top ring here. So if I go into set viewport to front, we can just come in and grab these and enter. Now I want to do this procedurally, so this is using primitive 0 to 49 on the top. What I'm going to do is, because this is basically being informed by this, I'm going to go copy parameter. I'm going to say we want to do 0 through to this, so 0 to that, but then it's that minus 1, so we get 0 to 49 when it's resolved. I'll go delete non-selective, delete non-selected, and that'll give us the top ring, which is what we want. And then we'll put down a facet, and the facet node, all I want to turn on is unique points. So if I were to, I think we can do this with an exploded view. Yeah, so you can see this here. This is basically given, if I bypass this, we've just got the one ring, it's all connected. If I enable that unique points thing, it's given us each individual face as a piece of geometry, which is what we want. I shouldn't have deleted that, should have deleted that. Okay, so then I'm going to put down a copy and transform, and I'm basically going to say I want to move it down by the height of this thing. So I'm going to say, what do I want to say? I want to say bbox, and we're going to point at that facet there. So what's that, facet 5? And we're going to say d underscore y size, and then we're going to multiply that by -1. So what this is going to do is it's going to move it down by the size of this. And if we increase this, we can eventually fill this back out. And again, what I'm going to do is I'm going to grab this number, because I know these two are related. I'm going to say it's this, but we want to do -1, so that we get an accurate shape again. So this is basically this, and that's all good. So now we've essentially got our bricks somewhat defined. The only reason I've done it this way as opposed to simply doing the facet on the tube is because we want this copy number attribute, and I'll show you why now. We're going to put down a for each. I'll put down the for each connected piece and just delete the connectivity, and that's because I want to put copy num in this piece attribute here. So now when we run through this for loop, I'm just going to move this version of the setup over. When we run through this for loop, we're running over each ring here, and that's the value of the copy num attribute. This is what this bit of setup's for. Okay, so now that I have that, we're going to put down a transform, and I'm going to select this top node here. I'm going to go create meta import node. So I like to go rename this to something shorter. So we're going to come in here, and I'm going to do a certain amount of rotation per loop. So we're going to go 20, and we're going to multiply that by detail, and we're going to select our meta 1, which is this one here, and we're going to grab the iteration value, turn 0 if you can't find it. And so what we should get, if I turn off single pass mode, and and turn that off, is now each layer you can see we've got this kind of brickwork emerging from this. So once we've got that, we can come in and create some stuff. So I've got a couple of the bits in here. Essentially I want to get that normal thing again, so I'm just going to copy it from here. I have this wrangle, should really name these, but here we are. And then we're going to do a poly extrude, which again I'm just going to grab this expression. So what we're grabbing is basically the amount of thickness out of here. So let me actually come down and put this down. So we're grabbing the amount of thickness out of poly extrude 3 and then adding some bits to it so that it encompasses our wall. So if I were to reference, or I'll turn that on and reference this on, you can see, oops, doing it the wrong way around. I think it is. Let's just invert this. So we're going to say at P minus our center here, and oh no, oops, because I didn't turn this on, we need to use the existing attribute here, and we're just going to turn off output front, so we end up with these. So this should reflect. Oh, I think I was right the first time. I'm just going to put that down like that, and so there we go. So you can see each one now intersects through our wall, which is what we want. So then I'm going to put down a facet node again, and I'm going to use that unique points thing, and we'll give this thing some normals, which I believe are primitive normals. We're being initialized here because we're about to use those. So what I basically want to do is I want to be able to cut this, and you can see when I come down here, we're doing two booleans. We're doing one which is, if I connect this thing over here so we can see it, we're doing one version which is each row, and then we're doing versions that are all of the columns, all of the vertical slices. So what we're going to do in this wrangle is basically set some groups up that are going to allow us to control exactly which pieces come out of which, so we can stick them into the right boolean. So I'm going to put down a primitive wrangle here, and I'm basically going to create two groups. I'm going to say if at n dot y is greater than 0.9, then we want to put you in a group called tops. That equals 1. So good. And then we want to say if at n dot x, and actually we need the absolute version of that. So at the absolute version of at n dot x, so if it goes into the negative, it'll return the positive. If that is greater than 0.1, we want to keep it or put it in a group. Or if the absolute value of at n dot z is greater than 0.1, we can create a group. Group underscore side, sides equals, can't type today, equals 1. So that should create us a couple of groups here, which you can see it has done successfully. So now let's blast these away. Let's see what we've got. So I have tops here. I delete non-selected. This should give us all of the cutting planes that are going to be required to cut everything horizontally, so we can do that now. One thing I did do was I went in, I put down a point wrangle, and I basically said if so what do we need? We need we need the vector. We're going to create one called min, which is going to be get bbox min. There it is, and use 0th input. And we do vector max, and we need that to be get bbox underscore max, again 0th input. And we're basically going to say if the position in y is equal to, so we're going to use get component, we want min and component 1, so we get the y component, or at p.y is equal to get comp max and component 1. So if either of those things are true, then we remove point, like so. Cool. There we go. So what that should do, oh, where I've put something down wrong. Oh, okay, I'm missing semicolon. It's always a semicolon. Now you can see we've got something. So if I were to reference this, okay, we're deleting 1 too many. You know what? Let's get rid of the max. We don't need the max. We can just do the min thing because that wasn't the problem. There you go. So now we've got cutting planes that are appropriate for what we're trying to do. So let's put down a boolean here. Connect this into the left input. I'm just going to grab, I have a tool here that's going to get me an object merging real quick. It's just going to grab our geometry here. And so if we do this, we need to set a few things up. So we're going to go and set this to be a surface, and then we're going to do a shatter. What this should get us, and I'm just going to grab this thing here so that I can visualize all the different layers. This is basically a connectivity node set to primitive. We're doing a random from attribute based on class, primitive color, and then just exploded view based on class. So what this should get us is all of our different layers, and there's no extra geometry, nothing else, nothing is broken. So okay, that's cool. That's our first layer done. So now we need to blast away our sides group. So we'll go sides, delete non-selected, and that gets us all of this. What's referenced on? Something's referenced on. There it is. So that gets us all of these, and we're going to put down an assemble. Again, if I can type, we're going to do pack primitives, and we're going to put down an add. Delete geometry but keep the points. So that gets us points for all of these. And then we're going to fuse them. So if I come in here, just turn on the point numbers, you can see, I believe there's a good example. There are 2 points overlapping each other. So if we put down a fuse, we can just remove that. And then we want to basically do our normalize the normal direction again. So we're going to copy this, and we'll just paste it down. So this should give us some point normals all facing inwards. Let's turn those numbers off. That all looks good. And then I'm also going to create an attribute called up, which is a vector. So we're going to say 0, 0. So now we've got this. So now what I've got is the ability to grab a set of points based on each of these, or each of these cut slices here. So I'm basically going to put down a for each connected piece, plug that into our boolean here, and I'm basically going to go and say in a wrangle, let's get the each slice. So if we look at this here just quickly, this is going to run on each of these with no guarantee which one is coming in which height, so we just need to pull that. So I'm going to say let's get let's create a vector called center, and we'll say get bbox center, and we don't want the 0th, we want the first input. And then we're going to say if at p.y does not equal our, so let's go get comp and center, we want the first component, so we get the y. So if our position in y for one of these points doesn't equal the y center of what's coming through here, we're going to remove it. So we'll say remove point, 0, comma, num. There we go, that looks correct. So you can see now that was working. This is the ring we're running on, and we're going to use these points. So now I can put down a couple of points, and we want to make sure that's in the second input. We're going to put down a grid, and I'm just going to make this 2 by 2. Let's copy that in. What do we get here? Okay, let's put them. Yep, that looks correct. and they're definitely big enough to cut through the thing. So now, again, we can do a Boolean, and we can go that in there, and we're going to say this is a surface, and we want to do a shatter based on that. And that should be enough to give us, yeah, there you go, a unique brick per ring. So that's cool. The only thing we need to do now, I believe, is fix its normal. So let's just run this over all 10 rings. There we go. I'm just going to right click here and turn off textures so we don't see the UV display. Looks okay. I'm still going to give it some normals anyway. Actually looks better than that. There we go. And there you go. So that should be a way of getting unique bricks based on that incoming piece of geometry there, and you can see we're able to preserve the shape we created up here. So if I want to, you know, come in and adjust this, I probably wouldn't adjust it with the Booleans live, but let's just do it with this displayed on. We can say, okay, let's make this, and let's do it just on the line. So let's make this a little bit, let's pull that in, maybe want to move that up. Let's get something a bit more square, bring that down a bit, and now we've got a whole new thing. This thing is developed procedurally as well, so we can come in and say, okay, I want smaller bricks, or thinner bricks in this case, we'll make them more regular, and we can run over this. I'm not going to do that because it's going to just recompute everything, but here you go. We'll do the same thing, shouldn't take too long with that number of bricks, and you can see that shape is preserved up there, and we get all of our bricks, and then you can kind of do what you want, whether that's, you know, turning them all into VDBs and getting mortar in between them and whatever else, but I'll leave that to you because it's gone on long enough. I hope that was useful. Apologies if not. Best of luck with the project.